Earth's most advanced billion-dollar humanoid robots will fail on Mars in exactly 11 days. In the next 4 minutes, we'll expose the fatal engineering flaws of the Silicon Vanguard and show you exactly how they must be redesigned to survive the Red Planet. The enemy isn't the 0.38 G gravity. It's the microscopic, electrostatically charged regolith. Martian dust particles are smaller than 5 microns and penetrate every unsealed crevice, causing rapid abrasive wear and catastrophic short circuits. Furthermore, standard Earth-based lubricants become completely useless. When the temperature plummets to -60 degrees Celsius at night, normal oils freeze solid, turning the robot's agile joints into useless concrete. Without radical redesigns, the first robotic explorers will simply become expensive monuments in the red dust, completely paralyzed and alone. Even if they survive the elements, we cannot simply drive them with a joystick. Depending on orbital alignment, the communication delay between Earth and Mars ranges from 4 to 24 minutes one way. If an autonomous robot makes a fatal error, it cannot wait 40 minutes for Earth to send a correction command. Moreover, surface radiation is 200 to 300 times higher than on Earth, which will instantly corrupt standard computer processors without triple modular redundancy. To survive, the Silicon Vanguard requires hermetically sealed Kevlar suits to block dust, solid molybdenum disulfide lubricants that ignore the cold, and an entirely new level of athletic intelligence to operate without Earth's help. This brings us to a massive engineering dilemma. What would you trust more with a multi-billion-dollar mission? Should we let AI think for itself? Or remote if humans must maintain absolute control? Once adapted, these machines become the ultimate workforce. Utilizing swarm intelligence, they operate in perfect coordination 24 hours a day, requiring no oxygen, no water, and no sleep. Before any human steps foot on the planet, the robots must utilize in-situ resource utilization. They will use specialized 3D printers to melt the toxic regolith, building massive radiation-shielded habitats out of native Marscrete. Simultaneously, they will construct automated Sabatier reactors, stripping carbon dioxide from the thin atmosphere and combining it with mined ice water to synthesize the methane fuel required for the return journey. When global dust storms strike, blocking out 99% of the sunlight for weeks, human crews will be forced to hide. The Silicon Vanguard simply recalibrates its sensors and keeps building in the dark. By the time the first human crew finally arrives, they will not step onto a barren, hostile wasteland. They will enter a fully functioning, pressurized, and fueled metropolis, prepared entirely by machines. On the surface, carbon and silicon will work in perfect synergy. Humans will provide the strategic intuition and creativity, while the machines will endure the extreme physical burdens of the Martian reality. But this creates a terrifying paradox. If the robots can build, mine, and survive completely autonomously, while humans remain fragile, expensive, and vulnerable, who is actually in control of this new civilization? Are humans the masters of Mars, or just the fragile pets of a super-intelligent machine network? Subscribe to Terra Nova Mars and discover the chilling reality of AI evolution in our next episode.